Okay, first I give a short introduction of myself. Perhaps I mean, it's the first time for me in the US since a long time. I'm more focused on Europe. So I'm the Ceph ambassador of the DACH region. I'm Ceph Foundation member of the board. I was previously a SUSE enterprise principal consultant. It's also I'm working for we worked for Red Hat as an enterprise consultant in Europe as well, just as an external company. Yeah, and I started in production with Firefly with Ceph. So when it was really a funny time, I would say, for an engineer, not for someone else. So yeah, sorry. Is this better now? Okay, good. So the company is founded in 2010, focused on infrastructure and platform as a service, based in Munich, and we are proud to be the member of Linux Foundation, Ceph Foundation, and also Cloud Native Foundation. So dynamic multi-cloud cluster management. First of all, I want to give some key facts because this project already started in 2020, and it will, I think, will go on for additional 2 years. So, the main keys are to have no vendor lock-in, open source, scalability, and so on. Pure IPv6. Everything is in this project is Kubernetes driven. Only microservices are the workload, and also used in the core. And it's a project that's coming from the public cloud, and it's going back into the on-premise private cloud. And it has at the moment somehow a bit more than 200 petabytes of RAM footprint in production. But it's also one of the projects where we don't count at the end the storage capacity. We just orientate on the RAM, how much the project or how much the production environment will consume or already consumes. So the motivation for 50 or even more Ceph clusters and why we need this dynamic multi-cluster management solution is we have different project requirements. So we have exclusive use cases, we have shared use cases, we have failure domains, we have different availability zones, data centers, regions. We have security isolation. I mean, the talk before, we spent a lot of time in investigating how the Ceph CSI is doing encryption, how Rook is doing this, and also the underlay is completely built or based or rely on Ceph. So for the virtualization stack, for the out-of-band management, for all the services you need to run a cloud in the Kubernetes way, you have so much different requirements. Even this nice database as a service is even something where we could talk, I think, at least an hour on it. So when we come to the point that that the project or even the user requirements constantly changing, and even I think we talked today about this. Can a client explain you what kind of performance and what kind of capacity he really needs, and how is the outlook for the next 2 years? It's quite hard for them even to somehow report, okay, we have at the moment this I/O or throughput need, and that will grow or perhaps will shrink next year. Even when some of them update their software stack, then they also have not the real information how this will impact the backend as well. And so out of this, it comes to a point that we can do some estimations, that we claim resources for specific customers, for specific projects, even for the internal infrastructure as well. but we are never right. It's just an assumption, and then we have to adapt it afterwards again. And for this, we implemented this dynamic multi-cloud or multi-cluster management that we somehow can create elastic backend that can adapt dynamically to the demands of the application stack above. So what does it mean? 1 second. What does it mean? I mean, what we do is we have different resource pools that are completely managed by Kubernetes. So we have no control over this. We get different events that explain us, okay, so we need resources from this pool, and here, or this Ceph cluster is elected to give some capacities back to a common pool because someone else already is somehow at the limit. And so we start processing to add and remove Ceph nodes from one cluster and also introducing them to another one, completely controlled by Kubernetes. And we have the control, or not we, but Rook, Ceph has the control over the data and how it should be managed. But the events that are created to distribute the data or the Ceph nodes, yeah, that's 1 second. Yeah, so once again, Kubernetes is informing us what Ceph should do. Ceph is taking care about how it should train Ceph nodes, and inform also Kubernetes that it will be possible or even not possible to train them, and then it will give it back, and Kubernetes takes it into account and bring it to the next cluster again. So I think that's not on this slide, but I will explain it later a bit with an example. In the upper, so we also changed some parts of Rook. We also refactored Rook at a certain point. We also said, okay, who is responsible for what kind of management? And that's just one example that we said, okay, we should delegate the responsibility to scaling the Ceph monitors back to Kubernetes. Because when Rook was introduced, there was only a deployment available to manage replica sets, and I think 2 years later, then the stateful set was introduced to Kubernetes, and this one can take over or can guarantee that the Ceph monitors will be scaled one in the right way. It will be during the upgrade phase, that only one is always down and the other ones are available. So that's something out of the scope of Ceph directly. So, and this is the part I was talking previously before. We get a Kubernetes event, adding nodes. We're adding the nodes to the crash route staging, doing the OSD test, doing the benchmarking, doing the classification, because we have different fast and slow device or hardware storage classes in Kubernetes there, and then waiting or checking if the cluster load is below a specific threshold, and then we move the crash, the one node or the multiple nodes from the staging route to the prod route, and so that the customer experience is experiencing no difference in latency, IOP, or throughput delivery. And also, an example how this is implemented is that how you remove a node from an existing root cluster. That you say, okay, I have the Kubernetes controllers told you, okay, we need a fast or a slow node from this cluster. Please free it up. Then Rook is verifying the user capacity. use capacity and say, okay, we have enough capacity in this cluster, we can give it back to you. Then the next step is do the verification of quality of service requirements. We have also in this an extension to Rook that every RBD image and has an IOP and a throughput definition. Before we introduce the cluster, we do a basic test or load test. We try to find the boundaries of the existing cluster that we initially deploy, and then we can somehow create an estimation how many RBD images of this specific storage class with 100 IOPS or 200 IOPS and 50 megabyte of throughput we can deliver. And when we remove a node in this case, then we also have to reduce the images that we can deliver with a specific quality of service requirement. In the next step, also we verify can we still handle the failure domain across, if you have, for example, a cluster deployed across multiple availability zones, and your capacity is, you could remove a node or multiple nodes capacity-wise, but perhaps you cannot even compensate a failure of one A set anymore. Then it would be also taken into account in this process, and perhaps it would be also denied. Then it's the same that we also say, okay, you have perhaps high usage on this cluster at the moment, and it would be not a good idea to even put more load on the cluster at this point to say, yeah, we just wait perhaps a day or even a week, or we have a specific defined maintenance window, and then the load goes down, and then it's a good point to remove the nodes from this production cluster. And give it back at the end when it drained to Kubernetes. And drained means that we really move the data away so that the replication is always at 3, or the erasure code is always completely fulfilled, so that we never end up in a situation that perhaps a node reboots or something like this, and then you can only, you would end up in a read-only Ceph cluster state. So what we also did in this time was we extended Rook, that Kubernetes is more, Ceph is a data awareness, or I always say the leader at the end who makes a decision if you can how you can manage a Ceph node in Rook. We also removed some features like the PG autoscaler, or disabled them. We also together with the customer, we agreed at the beginning that we should not use CephFS if possible. I think that perhaps will change in the next 2 years, that the requirements will come again and again on the table that they will need CephFS again, and also that they will handle the distribution of objects via RGW on a higher layer, not in the backend of Ceph itself. What we also did, we extended the health states of Ceph at this point. We have to differentiate between data replication, data health, and for example the status of the service. We have to We also have to suppress for this some health states of Ceph. For just a simple example is the crash warning that we have to suppress because it's not manageable in a setup like this. So what we did is, okay, we set the warning for the crash topic to ignore or to suppress it, and just send the events to a central facility that this will analyze what happened in each Ceph cluster. We extended also Ceph for Ceph or even Rook with additional recovery options, so that we also can interact with the OSDs if there is really a problem. And we also extended the RBD metadata in Ceph itself for this project, so that you can store different metadata that's not in the direct context of Ceph or even RBD. That's an example for the metadata is if you want to have a virtual if you want to use it for a virtual environment and you want to add RBD images to a virtual machine, and you want to have it always in the right order, you need something like a worldwide name that you really can identify. Okay, that's my disk at this position in the virtual machine. And like mentioned before, we already improved a bit the RBD encryption for Ceph CSI, but I think last week we decided to completely re-implement it because we don't see that the passphrase to de and encrypt the keys, the deluxe keys for each image should be stored in the Ceph CSI. So at the moment, last year we did a partial production setup that was around about 300 Rook clusters between 16 and 35 OSDs, so quite small. We tested several improvements in the setup, and even it's still running in production. We now go more in the larger scale setups. So they are building up the Ceph cluster at the moment. Round about 20 to 30 clusters are in production, but will be added more and more in the next few months. 3 new regions are built. They are building up at the moment, and because of this, also the data center fail domain is still in progress. So, and also now after around about 2 years, decision was made that we will support virtual machines with the standard Kubernetes PVC stack, because it makes the handling much more complicated. And the Ceph CSI is also somehow a limiter to use all the Ceph features that are really available. And I think with the SmartNICs, it's still in progress. We had a stronger focus on this, especially also with NVMe over TCP for security isolations. The one idea was to implement or to directly use the NVMe over Fabric client of the SmartNIC, and directly connected to the project of Ceph with NVMe over Fabric as security isolation, and also hide even the informations of the Ceph client for clients that have direct access on the hardware as well. So what we achieved is that from a client perspective is you have a hardware node, you see disks in the hardware node, but in reality it is just a mapping of the SmartNIC on this hardware node, where you have an RBD client that's with the config and the key that's just taking care of this as well. But it's one way to go, but it's not decided if, or it's not 100% production ready. Good. And yeah, if you have questions, perhaps I did it a bit wrong at the beginning, but it's also a quite complex project at the moment. And I'm involved in this since now more than 2 years, and it's really hard to compensate everything or to compress this in 30 minutes. So if you have any questions, then please.
Sorry, maybe I missed this. You said you're not using the CSI driver?
For the virtualization stack. So for normal Kubernetes clusters, so for client Kubernetes clusters, so we will use it, or we are using it, but we also have a virtualization stack that's consuming the Ceph cluster, and the decision I think was made last week that we will not use it anymore. That we have to re-implement it at the end. So there will be something, but without any PV or PVC, because I mean you have to think about this. We are talking about 10,000 of virtual machines, and it brings no benefit for the underlay that you handle it like this. And there's also, I mean, there are a lot of other services as well, and one is just taking care already about the quality of service and how many images are allowed to be created on one single Ceph cluster. And this can take also over the part that's normally the Ceph CSI is doing. I mean, it is from a general overview, it's quite complex from all the Kubernetes events, even how the decision is made where an image will be created in a Ceph cluster. So and it's also not that transparent to us where this comes from and what is the real use case for it. So a bit blind in the underlay. Yeah. Yeah, correct. Yeah, partially. I mean, we have to remove a lot of stuff of this. And we have to also extend our services there. I mean, it's not the main part of us as a storage consultant. It's more or less the Kubernetes experts who do the decision, and we just support them how they should do it. Yeah. 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 I think they try to stay with Kubernetes, with the whole design, and follow all of this, and then they realized after a while that it is not sufficient enough. And we have different other problems as well. How many pods you can deploy on one server, one physical server, to get rid of these limitations as well. But it's everything more Kubernetes related. Yeah. Yeah, with this setup you can do more. Yeah, the requirement for this I think is above 800. So Yeah. Okay. Some other question? I mean, if you want, I can show you what we else do there as well, if you're interested. So, like I said, the NVMe over TCP, SmartNIC support with 100 gigabit. We also then topics like ECN, DC, TCP. That's all the part in the pure IP stack, IPv6 stack. I think what I also not mentioned is that the Ceph clusters and everything else is just run with BGP. So no layer 2 anymore. Then we are working on the implementation of UBLK with IO ring for RBD. Backup, daily backup at exascale. We will improve Rook with Ceph day 2 operations. We all still have a look on C-Star and Crimson for the next OSD generation. In parallel, we try to improve the performance of BlueStore as well. We are thinking how we can integrate backup strategies within the Ceph technology stack, specifically for Kubernetes again, because if you think that all or most of the backup solutions come from Kubernetes sites and all the time tries or backup your whole PVC and the rest of and all the metadata of your Kubernetes cluster, there's also some better approaches how you can use all the features in the underlay for Ceph to make it a bit more efficient with data export for RBD as an example. We are still on this topic with Ceph namespace implementation in the build QEMU. I think that's open since 3 years. So we will see if this. Sorry. It's not. I mean, the ticket for this is I think 3 years old, something like this. At the last time when we requested or when we asked for this, then they just ask us for what customer, what is the customer who wants to have this? Yeah.
I think this is already supported because I had filed a bug 4 years ago, I think, about that same issue.
Yeah.
It is working as far as I know.
That you have that you can use RBD namespace, the pool namespace inside of this. Okay.
Short change to the TV driver. I forget it.
Yeah, I mean, yeah. So from my what I know, but I will double check this. Thank you for this. Then also storage as a service, and we are also working on some Ceph FS improvements, and we are really interested in the S3 zipper project as well. What's going on there as well, especially also what SUSE is doing with this S3 RGW. Patrick, is it the right name? Okay. I just saw it because last time on FOSDEM. So that's it. Good. Okay. Thank you.